Hello students, once again welcome to Bholanath Academy. In this video students, we are going to see the chemical properties of alcohols as well as phenols. Now students, when you are going to study the chemical properties students, so here students, we will see the laboratory test. We have to do some test of alcohols as well as what phenols. So students, when you see in laboratory students, every time you have litmus paper. With the help of paper, if you want to identify alcohols and phenol students, so what you will do students, with the help of litmus, we are going to test alcohol and phenols. So what happens students, we will take the aqueous solution of alcohol, in that we are going to dip the litmus paper. Now students, when there is no change in color in litmus paper students, that means alcohol, that is we are showing with ROH, aliphatic alcohols. If there is no change students, that means all alcohols are neutral in nature. Phenol is also a transparent liquid students. How you will identify between these two liquid students? When you touch the litmus paper to aqueous solution of phenol students, the litmus paper turn into red color. Okay students, if blue litmus paper turns into red color, that means phenol is present, which is acidic in nature. So this way students, you can identify the acidic and basic character of alcohols and phenols. If litmus paper is turning red in color, that means this is phenol. If there is no change in the litmus paper, we call as what? Neutral. Alcohols are mostly neutral in nature and phenols are acidic in nature. This is the first test students. Second students, reaction with bases. Okay students, in laboratory also students, you have sodium bicarbonate, NaHCO3, you have sodium hydroxide and sodium metal. Sodium bicarbonate, this is sodium NaHCO3, that is sodium bicarbonate. It is weak base and sodium hydroxide is what? Strong base and sodium metal. Now what happens students, when you add this weak base to alcohol? When you add weak base in alcohol, what happens students? There is no reaction. You will not find any reaction. Now what happens students, when you add same weak base, when you are going to add in phenol, both are transparent liquid students. When you add, there is no reaction. Understanding? There is no effect of weak base on alcohol and phenols. Understanding? Because there is no reaction. Now what happens students, when you take strong sodium hydroxide solution, that is 4 normal, it is there in lab students. When you add to alcohol students, what happens? When you add strong base in alcohol also, there is no reaction. Now but what happens students, when you add sodium hydroxide phenol, so there is a reaction will take place students, and there is a formation of sodium phenoxide. This is sodium and this is called as what? Aromatic oxide. That is, if it is phenyl group, phenoxide we call as, there is a formation of salt, that is PPT is formed along with water molecules. Now what happens students, this PPT, when you add, if you add HCl, you will find again phenol will come back and there is a formation of salt. So this way students, if NaOH is strong base added to phenol, it will form salt, and this salt students, if you add HCl and you are getting phenol. So this way students, you can identify the phenol is present. This way we are going to separate. If mixture is given, this way we are going to separate the phenol. Now what happens students, how to identify this is alcohol? For that students, you have to add sodium metal. This is the sodium metal. It will form sodium alkoxide. This is sodium and this is what? Alkoxide. There is a formation of sodium alkoxide, along with there is a liberation of hydrogen gas. This liberation of hydrogen gas shows that this transparent liquid will be your alcohol. So this way students, we can test whether the compound is alcohol or phenols. So phenol will always react with strong NaOH and it will form sodium phenoxide. If you want to add HCl, again you will get the phenol back. If you add sodium metal to alcohols, there is a strong liberation of hydrogen gas. These bubbles will show that this transparent liquid will be your alcohols. Understanding students? So these are the reaction with bases students of alcohols and phenol. Now students, we are going to see the characteristics for phenols. There is a characteristics test. Phenols react with neutral ferric chloride, FeCl3. All phenols react with ferric chloride to give deep color, that is the color may be purple, violet and green. This test will shows that phenol is confirmed. Understanding students? So this is the AROS, that is aromatic hydroxide, we call as phenol students. This is phenol. So and this is called as ferric chloride. So this is the characteristic of this test students for phenols. So if you add FeCl3 to phenol, you will find triferric phenoxide, iron phenoxide you are getting, that is deep in color, and you are getting HCl. Understanding students? So here students, Fe3 plus. Phenol react with neutral ferric chloride to give deep color. This color will shows that phenol is present. So this is the characteristic test for phenol. How you are going to distinguish the alcohols? We have primary alcohols, secondary alcohol, and tertiary. So for that, students, there is a test we call as Lucas test. It depends upon the reactivity. This is alcohol, students. It's three types: primary, secondary, and tertiary. Now what happens, students? In presence of HCl and zinc chloride, it will form alkyl halide. This alkyl alcohol will convert into alkyl chloride. Okay, students. From where chlorine will come, students? When you add the mixture of zinc chloride and HCl, there is a formation of alkyl halide. That is mostly because zinc chloride is containing chlorine, so the compound will be obtained will be alkyl chloride. This will be always alkyl chloride. This is R stands for alkyl and Cl stands for chloride. Now because of that, the formation of alkyl chloride, there is a called as precipitate of alkyl chloride, which turns solution turbid. So this turbid solution, when the precipitate, if your alcohol is primary alcohol, if you have taken the alcohol, if it is primary, for that, students, heating is required. Then only you will get the PPT of alkyl chloride. Understanding? Now if it is secondary alcohol, students, heating is not required. Slowly it will form the PPT of alkyl chloride. Okay. Now students, if it is tertiary alcohol, students, it will form the alkyl chloride very fast. Okay, students. So formation of alkyl chloride, from the reactivity only you comes to know whether it is primary, secondary, and tertiary. From primary alcohol, students, heating is required. For secondary alcohol, no heating is required. Slowly it will form the alkyl. And if it is tertiary alcohol, students, it will form PPT very fast. So depending upon the reactivity, students, by observing the reactivity, you comes to know whether the alcohol is primary, secondary, or tertiary. Okay, students, if react very fast, you can say the alcohol will be primary alcohol. If it is forming PPT very slowly, so you can say it is secondary alcohol. If it is not forming the PPT, you have to heat the solution with zinc chloride and HCl with alcohol, then it is forming the PPT, then we can say it is a primary alcohol. Reaction due to the breaking of oxygen and hydrogen bond. Now here, students, first we will see the acidic character of alcohols and phenol. If you want to study the breaking of oxygen hydrogen bond, that is hydroxyl group which is attached to alkyl group, this students, this hydroxyl group, in a hydroxyl group you have oxygen and hydrogen. So there is a breaking of bond between oxygen atom and hydrogen atom. Because of this breaking, students, the reaction is taking place. That is, we are going to see the reaction due to breaking of oxygen hydrogen bond. Now, students, before that, students, we explain the acidic character of alcohols and phenols. Why alcohol is neutral and phenol is what acidic in nature. With the help of these, students, you can explain the acidic character of alcohols and phenol. The reactivity of alcohols and phenol toward ionization of hydrogen oxygen bond in them is different. How you comes to know the alcohol is neutral, students? There is a breaking of bond between oxygen and hydrogen. In alcohol, students, that is we are showing with ROH, where the breaking of oxygen and hydrogen bond, when you add in water molecules, students, it will ionize and it will form alkoxide ion. Okay, students. Now the electron density is towards the oxygen. Now what happens, students? Because of that, students, it will form the hydronium. This hydronium ion will again combine because it is unstable. Alkoxide is unstable ion. Because of instability, students, now it will react again with the hydronium ion and it will form the alcohol and water molecules. Okay, students, because alkoxide, when you add alcohol in water, students, it will form alkoxide and hydronium ion. Because alkoxide ion is unstable, again it will combine with hydronium ion and it will form the alcohol and water. So because of this instability of alkoxide ion, alcohols are what? Neutral in nature. All alcohols are neutral in nature. Understanding, students? Here also, students, when you add phenol in water, students, there is a breaking of bond of oxygen and hydrogen. Because of that, students, there is a formation of phenoxide. This phenoxide will be stable ion. This is stable, students. You are finding this ion, phenoxide ion. This is phenyl group which is attached to the oxygen. We call as phenoxide ion, which is stable. This phenoxide ion is stable, and you are getting hydronium ion because of this, which is acidic in nature. So you are getting more hydronium ions. Because of this, students, all phenols are acidic in nature. This way, students, you can explain the acidic and neutral character. That is, as phenol is acidic in nature and alcohol are neutral in nature. So you can explain the acidic character of alcohols and phenol. Phenol is more acidic than alcohol. So in examination, students, sometimes they may ask why. So this way you have to write down for 2 marks in board examination they are asking. So this way, these two reactions you have to write down. Students, we are going to see the esterification. In breaking of bond between oxygen and hydrogen, students, the esterification reaction is taking place. That we are going to see, students. This is second reaction that we are going to see. The reaction between the reaction between alcohols and phenols with carboxylic acid to form ester is called esterification. Ester is formed. The reaction between alcohols or phenols, whether you are taking alcohols or phenol with carboxylic acid to form ester. The formation of ester is called esterification. You are fixing the ester. So students, whether you are taking alcohols or phenols with carboxylic acid, this is first two reactants alcohols, whether you are taking alcohols or phenols, and your second reactant will be your carboxylic acid, and they will form the ester is called as esterification. So first students, we are taking very simple in general. Suppose we are taking alcohols. Alcohols we are showing with formula ROH. This is the alcohol students. Now when combines with carboxylic acid, in general students, we are taking the structure of carboxylic acid. This is the carbonyl 2 valency, one valency by alkyl, other valency by hydroxyl group. Okay students, so this is your alcohol students, and this is carboxylic acid. In presence of acid students, what happens? The hydrogen of alcohol now combines with hydroxyl of carboxylic acid, and there is a formation of water molecules. Now what is remaining students here? It is alkoxide. Now this alkoxide, alkyl with oxygen is called alkoxide. Now it will join with the carbonyl of this carboxylic acid, and like this it will join with the carbonyl. This is CO carbonyl of carboxylic acid, and it will form ester. This formation of ester is called esterification with alcohols. Same way students, if you are taking phenol, aromatic alcohol, that is AR phenol, this is the phenol students. What happened here? Also you have to add carboxylic acid. In general, this is carbonyl, one valency by alkyl, other by hydroxyl. Presence of acid, the hydrogen of phenol now combines with hydroxyl of carboxylic acid. This is carboxylic acid. Now it will form water molecules. There is a removal of a small molecule of water. Because of this removal students, they will condense. Here phenoxide, ARO, is nothing but phenoxide, now combines with the carbonyl of carboxylic group. Like this students, it will combines. So this will form aromatic ester. This is aromatic ester. So students, aliphatic ester, for aliphatic ester students, if you want to prepare aliphatic ester, you have to take the alcohol. If you want to prepare aromatic ester students, you have to take the phenol. Mind well, this is very important for the examination point of view students. Suppose students, you have taken alcohol. This is alcohol students. Alcohol. Suppose you don't have carboxylic acid, so you can use anhydride. Action of acidic anhydride on alcohol students. So this is oxygen 2 valency. Either also carbonyl group, and this side also you have carbonyl group. This is acidic anhydride. This is acidic anhydride in presence of acid. What happens students? In presence of acid, here the breaking will take place. Breaking of oxygen hydrogen bond of alcohol. This is alcohol. Understanding students? So this hydrogen now combines. It will suppose here it is R dash, and this is R. Now it will combines with this students, and it will form R dash COH. There is a formation of acid. This is carboxylic acid, and what happens? This alkoxide, RO, is called as alkoxide, now combines with this, and it will form. Again you are getting ester students. So aliphatic ester you are getting from alcohol students. You are getting aliphatic ester. Same way students, suppose you have taken phenol students. When you add acidic anhydride, oxygen 2 valency, this side also carbonyl group, and this side of oxygen is also attached to the carbonyl group. Now in presence of acid, now what happens students? There is a breaking of oxygen hydrogen atom. Now this hydrogen of phenol combines. Now here students, you can take anhydride like this. This is suppose R dash, and this is what R. Now it will combines with this, and it will form R dash COOH. This is nothing but carboxylic. This is acid students, and you have now the phenoxide is remaining. Now it will combines with this, and it is forming aromatic ester. There is a formation of aromatic ester. So this way students, you have prepared the aromatic ester from acidic anhydride. In examination they may ask action of acidic anhydride on phenol, so you are getting aromatic ester and acid. Understanding? So this is our product. So that is why it is called as esterification. Again we are getting the product as a ester, so this reaction is called as esterification. Action of acetyl chloride on alcohol and phenol. Third reaction students, suppose you have, this is alcohol, action of acetyl chloride. Acetyl chloride you can write students, this is acetyl group. Here the chlorine is attached. So it is called as acetyl chloride, or you can say acid chloride, or you can also say acetyl. Now what happens, students, when you add acetyl chloride to alcohol, there is a breaking of bond of oxygen hydrogen from here, students. This hydrogen combines with chlorine of acetyl chloride. Pyridine is required, students. In presence of base only it will react, it will form HCl. And now what happens, students, this alkoxide of alcohol now combines with acetyl and it will form ester. Again you are getting ester like this from acetyl chloride. Action of acetyl chloride on alcohols also gives you ester. This is also called as esterification with acetyl chloride. Understanding, students? Suppose you have phenol when combines with acetyl chloride in presence of pyridine. Now what happens, students? There is a breaking of bond of oxygen hydrogen will take place. The hydrogen of this phenol now combines with chlorine of acetyl chloride. If it is acetyl group is there, to we call acetyl chloride or acid chloride. Now what happens, students? In presence of pyridine, this hydrogen of phenol combines with chlorine of acetyl chloride and it will gives you HCl. Now what happens, students? This phenoxide now combines with this carbonyl group and it will form ester, but ester will be aromatic ester. So this way you have got the aromatic ester, students. So that is why this reaction is also called esterification. This is called esterification of phenols using acetyl chloride. This is very important in board examination also, they may ask. Okay, students, one more example that we are going to see, students, that is phenol. This is the phenol, students, to which acidic group is attached. When acidic group is attached to this phenol, students, we call as salicylic acid. Now to this salicylic acid, students, we are going to add acetic anhydride. So this is the oxygen having 2 valency. Here the acetyl, this is acetyl group, students, this is called as acetyl. On both the valency of oxygen is occupied by acetyl group CH3. So this is acetyl, this is also acetyl. So that is why it is called as acetic anhydride. Now what happens, students? Here the breaking of bond between oxygen and hydrogen will take place. This hydrogen of salicylic acid now combines with this acetate and it will form a carboxylic acid, CH3, CO and OH. That is called as acetic acid. Now what happens, students? This part will now combines with this acetyl group. So students, you are getting the compound like this. Now it will combines with COCH3. So this part will now combines with this and it will form common name we call as what? Aspirin, or you can say acetyl salicylic acid. This is acetyl, so we call as this way you can prepare the aspirin. So these are very important for the examination point of view, students. Like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.